Hello. Hello and welcome. If you need me to keep talking, just let me know, but we are waiting for a few more people to join before we get started. All right. So welcome to SciTech. And today we get to talk about solar energy in this program today. And my name is Sam, and I'll be your host. And we have some people joining from Zoom as well as YouTube. So I am going to go over a quick tutorial on how to use Zoom before we get started. But before we do that, for both our Zoom and YouTube viewers, I have a question for you all. And we have to test our solar IQ. So how much solar energy reaches the Earth's surface at any given moment? How much do you think? We have anywhere from 173 terawatts to 1.73 terawatts, 17,300 terawatts, or 173,000 terawatts. How much solar energy reaches the Earth's surface at any given moment? What do you think? You can type it in chat while we go over this Zoom tutorial. All right. Oh, and again, terawatts are trillions of watts. You can see down at the bottom here. All right. So with Zoom, we do have captions for this program. So at the bottom of your screen, you'll see that closed captions option. If you click on it, you can click show subtitle. And if you need to change any of the settings, like make captions bigger or smaller or anything like that, you can click on subtitle settings as well down at the bottom here and change those settings. For the best view of this program, so you can see both Laura and her presentation, we recommend doing side-by-side mode, which you can find in this view options bar at the top. You can click side-by-side mode and then click side-by-side speaker view over on the right here. And then that way you can see Laura as well as her presentation. You can also adjust the size of the presentation versus the camera with this bar here in Zoom. So if you click on it and drag, you can change the sizes of your windows there. And finally, we also have the chat. Please use that to ask questions and make comments. And please remember to be a good digital citizen, so respect your fellow viewers. And then also make sure that your comments and questions stay on topic. All right, so with that, we have the answer to our question of how much solar energy reaches Earth. And it is 173,000 terawatts. So we have solar energy being the most abundant energy source on the planet. So if you can imagine, enough sunlight hits the Earth's surface in 1.5 hours to power the entire world's electricity consumption for a year. So 1.5 hours for a year. Imagine if we can harness all of that. That would be awesome. All right. Great. So with that, I want to introduce our speaker for today. We have Laura Combs here, and she is Eagle Solar and Lights Business Development Director in North Carolina. She has a master's degree in urban and regional planning with a specialty in environmental planning. And she's a former government and nonprofit employee who worked to recover the endangered Florida manatee, which I have to ask you about. But she is very aware for the need for maintaining slim overhead and maximizing funds, and she is grateful for the opportunity to help protect the planet while helping people to reduce their carbon footprint and utility bills via solar energy installations. Thank you so much for talking with us today, Laura, and I'll let you take it from here.
Okay, thank you so much for the opportunity today, Sam, and for everybody's help in getting set up today. And I'm grateful for everybody who is celebrating Earth Day today and participating in efforts to create a brighter, better future for all of us. This is something that I've been passionate about and working on since I've been basically 8 or 9 years old, and that was a really long time ago, far too long ago. But you know, something that you can't stop doing, especially once you know how to do it and you get the passion for it. So I'm grateful for everybody who's here today, and looking forward to sharing a little bit about solar energy. And I'm going to share my screen right now and then dive into all of that. So let's hope that I share the right screen, because I had a kerfuffle today or discussion. And a little bit of background, I'm a homeschooling parent and had the honor and good fortune to homeschool my son for 18 years. And as part of the way I approach education, it's not just one little slice of a topic. It's a great big bunch of topics. So today we're going to cover chemistry, physics, biology, math, English, history, economics, and more, all crammed into about 45 minutes, possibly less, if I'm on a roll. But before we get started, it is Earth Day, and I need to give a shout out. I'm a science geek, and a space geek especially. And I caught part of Shawn Mendes's Earth Day Q&A with the International Space Station astronauts, and that recording is available. So I urge everybody who has the opportunity to go look that up. You can listen to it, watch it. Earth Day Space and Q&A with Shawn Mendes, and watching him make contact with Houston and then the astronauts all the way through the point where the astronauts leave the scene is just super cool to watch. So, a very, very fun day today with a lot of great opportunities. So let's get into what we're going to cover. I'll just give you a teeny bit more about me in a moment. We'll talk about the sun and the earth and climate change and renewables, the history of solar energy, generally how solar energy works. There's all kinds of engineering and chemistry and details, but we don't have time for all of that. And then solar energy access for underserved or underrepresented communities. So solar and environmental justice. And we can take questions. I have a little break planned in here to see if there are any questions, and we can take some at the end as well. So here we go. So a little about me. I graduated in 1991 with my master's degree and focused on environmental planning, and was fortunate to start out in the manatee protection program in the state of Florida. And that was an amazing, amazing opportunity to learn how to be an effective and advocate and environmental professional. That eventually morphed into nonprofit work. And on the left-hand side, you'll see I am there with my one-year-old son. We were featured in Smithsonian Magazine for the work we did on manatee protection, my organization, and I was at ground zero of the manatee protection effort at that point. And the baby eventually grew up, and 18 years later, he's the tall guy on the right. And this is super cool, being involved with solar energy, because we get to touch on other fields as well. And so last summer, as I had been working with my company, Eagle Solar and Light, we were able to go out to a farm, Butler Farm, and Mr. Butler covered his hog lagoons, I want to say 10 years ago, and captured the methane and worked on a process to convert the methane into electricity. And he combined that hog lagoon methane with the solar installation that he put on his farm, and he now serves as backup power for his 25 neighbors and powers his entire farm this way. And so this solar journey that I've been on for a little bit over a year has been absolutely amazing, because it's so hopeful to see all the different efforts and ideas and just the ingenuity that people are putting forward to help make this world a better place. And so eventually, a little bit over a year ago, I was fortunate to be hired by Eagle Solar and Light, and it's been a great company for me to learn this part of my environmental journey and to learn about business and to bring forward environmental relief in an entirely different way, as opposed to the advocacy that I had been doing with government and nonprofit organizations. So with that, we'll dive in. And solar energy all starts with the sun. So we're going to talk about the sun a little bit, and it is 4.5 billion years old, and it's about halfway through its life. And the sun accounts for 99.86% of the mass in the entire solar system, and about 1 million Earths can fit inside the sun. But as the sun, runs out of its fuel and begins to shrink, it will eventually shrink to the size of the Earth and become a white dwarf. The sun's energy is created by nuclear fusion, which involves the combining of atoms, and its chief composition is 70% hydrogen and 28% helium. And the sun, everything's in motion. all the way down from atoms, subatomic particles up to our solar system and beyond, the sun travels at 220 kilometers per second. So for you Percy Jackson fans, this slide is for you, and we'll step back and see how people thought about the sun in ancient times. And the word sun can be traced back to ancient Greece and the Greek god Helios, who's the god of the sun, and he was born a Titan. And the frieze on the left is a depiction from the Temple of Athena, of Helios driving his chariot daily toward the sun with fire-breathing horses, and he delivers sunshine around the world. And eventually, the god Apollo gained prominence, and Apollo is not a Titan, but an Olympian, and he's known as the god of light. So people have been looking toward the sun, thinking about the sun, making up stories about the sun for, well before, 7th century BCE and before. The Roman Empire eventually dominated, and the name for the sun became Sol, as in solar system. And eventually, through the Germanic and Old English translations, we arrived at our modern name of the sun. So let's talk about the Earth, because we're the ones who have spent all this time worshiping the sun, looking to the sun, and taking advantage of the wonderful warmth and energy that the sun brings. And the word Earth is from the English word eartha and the Germanic word erda. And the Earth is the only planet not named after a Greek or Roman god or goddess. And the distance from the sun is 149.6 million kilometers, or 92.96 million miles. And the time for light to travel from the sun to the Earth is 8 minutes and 20 seconds. So 8 minutes and 20 seconds to cover 92.96 million miles. So the Earth's relationship to the sun has been an evolving understanding. And it was interesting to see it occur, or to learn about it occur over time through my physics classes in high school and college. And it was interesting to realize or understand that initially we were taught that the Earth, and humans thought about the Earth through what is called the geocentric model. And, basically the universe revolved around humans, around the Earth. And that is what Plato and Aristotle talked about from the 5th and 4th centuries BCE. And Ptolemy, who's a Roman Egyptian, is ultimately given credit for developing the geocentric or Earth-centered model about 700 years after Plato and Aristotle. And just, think about that a moment. The humans thought that the universe revolved around them. And that's understandable for sure. But how does that play into our relationship or treatment of the Earth over time? And eventually, just as with language growing and the naming of the sun and the Earth growing and changing, so did our understanding of our relationship to the universe. And eventually, Copernicus scientifically documented that the geocentric model was wrong. And he developed the heliocentric or sun-centered model of our universe. And Copernicus's heliocentric or sun-centered model was published in 1543. And I found that to be so interesting because I also, learned that ancient Greece had been exploring this heliocentric approach as well. And that was new knowledge for me getting ready for this presentation, that the ancient Greeks were thinking that we traveled around the sun. So while Plato and Aristotle carried the day at that point, people were aware that there was possibly a difference. So in essence, it took about 2,000 years to scientifically document that the Earth moves around the sun. And Copernicus's discovery is credited with contributing to the beginning of the scientific revolution. And that has been an amazing journey. And we're going to see, as science gains more knowledge more history, it moves faster and faster. And we're going to see that play out in the development of solar power. And that was another interesting deep dive for me getting ready for this presentation. So climate change has been on everybody's mind. And I've always been a Lorax fan. And my son has read the book a million times, had it read to him a million times. And I love this quote. It's not about what it is. It's about what it can become. And this picture of the Lorax, I need to give credit. This is from the People's Climate March of 2017, somebody's drawing that they presented. And, you know, we are where we are with climate change. It's something that I had been trying to work to prevent since 1990 or even before, when before I'd gotten my master's degree. And here we are today, faced with climate change. And I'm hopeful because there's so much that we can do to offset or reduce the adverse impacts. And science and technology have carried us very far. And it's, you know, do we have the will to use what we've developed the way we need to? And so there are solutions, and energy reduction is a critical part of that. You know I've had this discussion with my son over the years, you know, turn the darn light off, you know, and understandably, one light, what difference does one light make? Well, not a whole lot, actually. One light does not make a lot of difference from one person, but each person taking one small action adds up to a whole lot of great big good. So if we all turn that light off, if we all, you know, reduce our use of air conditioning or heat just a little bit when we're able, if we're able, all those little reductions add up to a whole lot of great big good in addressing climate change. The next item would be energy efficiency. And not everybody is able to work on energy efficiency. Not everybody can afford to change out their light bulbs, for example, or they can't afford to put in new windows. They may need new insulation. And so fortunately, there are programs to help people with that who are unable to afford those efficiency improvements. And I'll talk about that in a little bit, but that's the next step. And then third, the part where I come in is the green energy. And green energy covers a lot of topics. And of course, there are a lot of modalities. There's wind energy and hydroelectric energy, geothermal energy, that's Yellowstone and the geyser over there, and people use geothermal to, you know, use the heating and the cooling that they need, or the heating, excuse me, and power that they need at their homes and other locations. And then, of course, there's solar energy. And right here, I just clicked on, this is an installation my company just completed for a nonprofit that helps people who are underserved, Benevolence Farm. And, you know, it's a great project to work on. This is a small project, but for them, it is a big deal. It's a relatively small project, I should say. But for them, it's a big deal. They're going green. They're demonstrating a green commitment. They're reducing their energy bills. And so solar can make a difference on many different scales for many different people. And so what's next besides these possibilities, wind, hydroelectric, geothermal, and solar? And this next part's cool because, as I said, Copernicus kicked off the scientific revolution, and that revolution is just cranking forward. So we're going to step back a minute and talk about the original solar panels, which are the plants. And you all have seen sunflowers, I'm sure, travel with the sun. We've all taken advantage of warming our bodies with the sun. I used to live in Colorado, and people would put earth ships into the sides of hills, and the sun would warm those earth ships and reduce their electricity usage. So we've got that passive type of use of the sun. The plants are the original utilizers of the sun, and we'll get into that in a minute. But there's another part to the plant story, and the online publication Energy reports that a researcher at MIT, Andreas Merschen, has found a way to create solar panels using agricultural waste. According to him, in just a few short years, it will be possible to stir up some grass clippings or dead leaves into a bag of inexpensive chemicals and paint that mixture on a rooftop where it can immediately start producing electricity. And that blew my mind when I was reading about that. His process works by extracting the photosynthesizing molecules from the plant matter that contain chlorophyll, which can convert photons into the flow of electrons. And we're going to talk about photons and electrons in just a moment. But the chlorophyll can convert photons into electrons. Once those molecules stabilize and are spread out on a glass substrate covered in zinc oxide nanowires, the sunlight can then be absorbed and turned into electricity. Essentially, Mershon replaced the layer of silicon in the conventional photovoltaic cells with a slurry of photosynthesizing molecules that he describes as an electric nanoforest. So all that from plants. So right now, you all know what solar panels look like, but eventually plants could change that entire equation. And that's very exciting because while solar energy is green energy, creating solar panels and disposing of solar panels have their own environmental cost. And to give a nod to the biology of the plants, and for all of you out there who are in high school studying biology, a quick look at the photosynthesis model, just because we can, and I'm a homeschooling parent, and that's what we do. So carbon dioxide, water, plus sunlight yields glucose and oxygen. And those photosynthesizing powers will eventually possibly be painted onto your roofs. So the history of solar energy and that scientific revolution is pretty amazing as I went ahead and researched that topic. And the use of solar energy as a tool began around the 7th century BCE, when magnifying glass-like materials were used to start fires. And from then, the race was on. And like anything, you know, the exploration and startup of an idea can take a while to grow. And we're going to jump many, many, many years ahead to 1839. And Edmond Becquerel, a young physicist who was working in France, observed and discovered the photovoltaic effect. And that's a process that produces a voltage or electric current when exposed to light or radiant energy. And then in 1884, Charles Fritts installed the first solar panels in New York City. And you can see them on the left in that picture. And selenium was coated with gold to help the transmission of that electricity. And then in 1888, Alexander Stoletov created the first solar panel using the Photoelectric Effect. And again, we'll talk about that in just a moment. On the left-hand side, those are our modern solar panels. That's Woods Charter School. That's a very large installation. You know, one that our company recently deployed, and in a little bit, we'll talk about optimal solar conditions, but Woods Charter with that flat roof makes it very nice to install solar panels. So now let's go a little bit further into the history. So Albert Einstein picked up on the photovoltaic research, and in 1904, he published his research, and he won the Nobel Prize in Physics for that, related to photovoltaic research. By 1954, the first solar panel was produced, and Bell Laboratories created it. And you can see there's a cable repairman adjusting a solar battery. And this is allowed the first sun-powered telephone call, and it was done near Americus, Georgia in 1955. Eventually, as with all times, things change, and they eventually became known as Nokia Bell's Laboratory. By 1956, the solar battery shrank, and Edward, I'm going to sadly pronounce his name incorrectly, probably Kianjian. Edward Kianjian holds a pocket-sized solar-powered radio that operates continuously in daylight and runs 500 hours in darkness without recharging. It was built by Kyonjin, and another engineer at General Electric. And now we're going to flip through a couple slides real quick, but solar panels and people's imaginations were taking off, and Dr. Schick put panels on his boat to have a solar powered boat. And in 1960, London produced the first solar powered car using a 1912 Baker electric car. And the panel was 26 square feet, and it was a 72 volt battery system. That's in 1960. By 1980, at the Winter Olympics in Lake Placid, New York, the solar powered phone was being utilized, and you can see how that was set up then. And by 1989, the 10 solar villages were in place, and Saudi Arabia implemented 251 solar cells, and it was one of 10 solar villages in 1989. And those look vastly different from the solar installations that we see, those utility scale solar installations that we see on the side of the road today. But I thought that that was really neat that, you know, one of the leading oil producers in the world was going solar back in 1989. Again, I'm a space geek, and Hubble Space Telescope is a project I've been following a really long time, and Hubble Space Telescope uses solar panels to do its work. And most excitingly, this past week, the Ingenuity helicopter, which is up on Mars, and I believe it just completed its second test flight today. That takes advantage of solar panels as well. So, you know, we've come a long way from magnifying glasses and fires to understanding, and again, I'll go into it in just a moment, photoelectric effect, photovoltaic effect, understanding those things to then implementing solar electricity to do our work not only on Earth, but in outer space and now on another planet. Real quick, just to look at some of the leadership around solar in the United States. And in 1979, Jimmy Carter had 32 solar panels installed on the White House. And I'm going to read this quote from President Carter because it summed up the thinking at the time, and he was definitely spot on and sadly, seemingly a little bit before his time. Quote, "A generation from now, this solar heater can either be a curiosity, a museum piece, an example of a road not taken, or it can be a small part of one of the greatest and most exciting adventures ever undertaken by the American people. Harnessing the power of the sun to enrich our lives as we move away from our crippling dependence on foreign oil." End of quote. Sadly, when Ronald Reagan took office, he had the panels quickly removed, and the White House stayed solar free until 2003. And I was excited to learn this. George Bush put solar panels back on the White House in 2002, 2003, and he had 167 solar panels installed that were used primarily for heating the water, heating the pool and the bathhouse at the White House. But that really flew under the radar, I think, of most people that he was responsible for that installation. Fast forward to 2013, and Barack Obama came into the White House as a very, very large solar advocate. And it's hard to track down for some reason how many, but he had more solar panels added to the White House, as well as championing solar to the rest of the country. And here we are today, and Joe Biden is putting forward just a great resources toward promoting green energy, solar energy. He made this great announcement today at his Earth Day Climate Summit of 50% reduction in US greenhouse emissions by 2030. And solar is definitely going to be a huge part of that effort. And at this point, this is a quick piece of art from a dear friend of mine who's a tremendously talented artist. I'm happy to take questions and then dive into the more of the science of and the physics of solar.
Wonderful, thank you. We have a lot of observations in the chat. There's a lot of and I agree with this too. Adam was stating that he didn't know how how early on solar panels were developed, like in the 1880s. And I didn't know that either. So that's so cool that they've just been around for so long. But yeah, I am not seeing any questions right now. So if you have any questions, please put them in the chat. But I did have a question for you. When you were talking about the electric nanoforests, so again, using those photosynthetic cells on glass panels being like the future of I had a question. How would we keep those cells alive? Would it be actual living cells, or would it be like a technology that's based on photosynthetic cells?
So sadly, we don't have the MIT researcher on the line with us. So I don't have a good answer for that at all. My guess would be that, they would not be alive. But I don't know. Actually, I can provide a link, and folks can go to that research. Yeah. I just was turned on by the idea and the creativity that people are putting into the future. I have a dear friend of the family, and he's just completed his sophomore year at Georgia Tech. And one of his goals is to try and figure out how to create solar producing sidewalks. And there are just so many different ways to provide the energy we need and to do it effectively, or so many different ideas. And some of those are going to come to fruition, which is why I'm so hopeful for, where we are now. And I'm going to dive back onto my screen.
Thank you. And yeah, I'm very excited too. There's a lot of really awesome things in development. So can't wait to see those come out in the future.
Okay, so yes, thank you, Greg Vineyard, my dear friend, for that wonderful piece of art. And let's talk about the photovoltaic effect and the photoelectric effect. And this is courtesy of Live Science. Hopefully I properly sourced all of my pictures that were not common. So the photovoltaic effect this is really neat. It involves photons, light photons, coming from a light source. And obviously the sun is our greatest light source. And in the photovoltaic effect, which was first discovered, the electrons are knocked out of their atomic orbits, but they are not leaving the material. And so they flow freely through the material. But the next discovery was the photoelectric effect, and that involves the light photons knocking electrons completely out of the material. And the photoelectric effect is what is used for solar energy. So here is a diagram courtesy of NASA. Again, me, the space geek, and NASA. And this diagram illustrates the operation of a basic photovoltaic cell using the photoelectric effect. And solar cells are made of the same kinds of materials as semiconductors, using, for example, silicon. And for solar cells, a thin semiconductor wafer is specially treated to form an electric field that's positive on one side and negative on the other. And when light energy strikes the solar cell, the electrons are knocked loose from the atoms in the material. If the electrical conductors are attached to the positive and negative sides, that forms an electrical current. And the electrons can be captured in the form of that and they can be captured in the form of an electrical current. You have to have that positive and negative attachment, and that forms a circuit. The attachments form the circuit, and then the electrons can be captured in the electrical current, which is then electricity. And the electricity can then be used to power a load, such as a light or a tool. So a solar panel starts with the solar cell, which you just saw. Multiple cells are placed together to become a solar module. And then multiple modules can be wired together to form a solar array. In general, the larger the area of a module or array, the more electricity that will be produced. And photovoltaic modules and arrays produce direct current electricity and can be connected as a series or in parallel, and I'm not an electrician, but in series or parallel, and produce the necessary voltage and the necessary voltage and current. So what does this look like for solar? And in solar, the most common installation is what's called a grid-tied system, where the solar production is tied directly to a utility company's utility grid. And if you look at this graphic, we've got the sun sending photons of light over to the solar panels, knocking around those electrons. Those electrons are being gathered up into the form of electricity. That electricity is in the DC or direct current form, which cannot be used by buildings. So that DC electricity runs through an inverter, which then converts it to AC electricity that can be used by your home, your school, or your work office. And that's, a beautiful situation. But sometimes you don't need to use all the electricity that the solar panels are producing. And in that case, the excess electricity goes over to the utility grid. And when it does so, it goes through what's called a bidirectional meter. And that meter acknowledges and documents the amount of electricity you're sending to the grid. And you get credits on your electricity bill for sending that electricity to the grid. The meter also documents the amount of electricity you pull from the grid, and that's how they determine your bill size. One of the things about a grid-tied solar system on your house or your school is that it cannot operate while the grid is down. Because if we have a significant storm and wires are down or broken, then folks need to go repair those wires, and there cannot be electricity flowing through those wires. So solar arrays are set up such that they have an automatic shutoff device so that the situation can be safe when there needs to be utility grid repair work done. Couple quick facts. Solar panels these days are typically warranted 25 years. The meter, that bidirectional meter that acknowledges the electricity you're sending to the grid and the electricity that you're pulling from the grid. When you send that electricity to the grid, it's called net metering, and you get those credits. And we'll talk about that more in just a minute. But one of the goals that my organization generally has is to prevent, too much electricity from flowing into the grid, because there's an issue with taking advantage of all of the credits. So let's talk about what are optimal solar conditions for solar panel placement. This is Carolina Day School, a system that Eagle Solar and Light installed, and it exemplifies a number of the good characteristics of a solar installation. We're looking for photons. We're photon hunting so that we can excite those electrons and generate electricity. South-facing roofs are the best roofs to have. East and west-facing roofs can also be very effective. Flat roofs can be effective as well. And at this building, this is not a flat roofed building, but we have installed on a number of flat roofs, and we'll be back up there installing on a flat roof shortly. So south-facing, east-west-facing flat roofs, on the ground installations where we can angle those panels to optimize the sun, or with carports, we can sometimes take advantage of the sun most effectively that way. No shading is ideal. You can see Carolina Day School has no shading issues. Properly sized photovoltaic system. Again, we don't want to produce too much, because there's a point at each year where Duke Energy takes those solar credits that people earn and they wipe the slate clean. And basically that's just free electricity. So we try to properly get that system sized. Favorable utility rates make solar much more economically outstanding. So the more that utility electricity costs, the more favorable solar becomes, because solar is offsetting costly electricity. There are 13 non-residential utility rates in Duke Energy Progress Territory, and there are 3 residential rates in Duke Progress Territory. And I mention that because each solar installation is unique. There may be some general rules of thumb, but understanding how solar performs is dependent on each building, its orientation, and the utility rates that are being charged. And a big part of optimal solar conditions is the Duke Energy rebate. And that rebate is available in Duke Energy Carolinas and Duke Energy Progress territories, and it is helps to dramatically offset the cost of solar. And I see I'm going to have to speed up a little bit. I could talk about this for weeks. Solar challenges, curved, slanted, or uneven roofs, architecturally inappropriate roofs. I love this building. This is the Lumbee tribe of North Carolina, their main meeting building. It's called the Turtle. It's a curved roof. It is a beautiful building, and in no way should solar be on that building, but it could be placed nearby on the ground. But that's a building that I've had the opportunity to take a look at. Oops, excuse me. And other challenges are slate roofs or small roofs. This is a organization that we hope to install for, except that their roofs are all slate, and the only appropriate location is this flat roof area in the red box. But you can see that it has utilities associated with it, heating, ventilation, air conditioning, that shades the area. There's really not much room here for solar. This is not a good place to install solar. And finally, and it doesn't apply to this building, but roofs in need of repair, buildings may need to have energy efficiency improvements, and there could be financing hindrances as well. I'm gonna move along quickly now. So solar and math. I'm a big math geek, big homeschooling geek. There's no one definition to math. And, most people think of addition, subtraction, multiplication, the number crunching part, but there's also a bigger part of math. And the definition I like to use is finding similarities in different things and differences in similar things. And that's from Dr. Maria Drushkova, and she founded Natural Math. And so the bigger definition of math comes into play when the actual installation of solar occurs. But for the number crunchy part, we look at kilowatt hours, kilowatt demand, and then we try and maximize the net metering opportunities. And this is a ground mount that we installed that takes optimal advantage of solar. Let's see, anything else I want to add? Here's a quick solar scenario sample, and this is 2 graphs, and it shows you on the installation that's being proposed. This is an overperforming installation because the utility usage is decreased thanks to the COVID mess. And you can see on the right-hand side, we've got these blue bars, and that represents energy usage, again, under representing normal usage because of COVID. And the orange is representing solar generation. So in June of every year, those utility credits are taken by Duke Energy. And you can see that in March and April and May, this array is overproducing and generating credits that Duke will eventually take and say, thank you very much, we appreciate that. But again, when this facility goes back online to its normal usage, the overproduction won't be as much. And you can see that the solar array will cause about $8,600 in savings. That's an estimate. So here, these are kind of like the solar superheroes. These are 3 of Eagle Solar and Light's installation team. They're on Temple Beth Orr, which we're installing right now, a solar panel system. And these guys take solar from concept. They take it off the page and they put it into life. They put it into practice. And so they're using that geometry, that algebra that's been studied in school. To watch them work in real time is pretty amazing. And to me, installing solar panels is a complex process, and the problem solving that these guys use when they're doing their jobs is just fantastic. And we all have our own talents. I am at the computer, but these guys are out there making it happen. So they're kind of my solar superheroes. Where's solar going? So solar, these are some headlines from this year. Solar's not slowing down. It's going to be the cheapest power source in the US by 2030. Renewables in 2021 are going to account for the most new electricity usage in the United States. And in North Carolina, we are the 3rd highest solar producing state. And it's responsible for about 6,600 solar jobs. You can see a lot of megawatts installed. We have 88 installers or developers of solar. And it's a really big business here in North Carolina. And that kid down on the left is mine, all sweaty in August, learning how to install solar thanks to the guys I showed you in the previous slide, and they're tremendous teachers. So the financial case for solar, we know the green case, we know the climate change urgency, but solar helps to reduce overhead and free up resources, whether, for nonprofit organizations, for families, if they can take advantage of that solar rebate that I mentioned. And so at the same time, reduce cost and help the planet. Real quick, I need to mention about solar and environmental justice and low to moderate income communities. And these communities often are left out of so many parts of advancement that we get to experience here in the United States. And so impediments to low to moderate income folks are lack of access to capital. Sometimes they earn so little that they don't even qualify for assistance. And I'm not sure how that works. If they're renters, they cannot install solar and they can't afford to become homeowners. If they live outside of Duke Energy territory, they can't take advantage of those rebates that are so helpful for those of us who do live in Duke Energy territories. And often they're unfamiliar with solar and who can help them. The solutions are green banks and community development finance institutions. And I am working very closely to try and find solutions for low to moderate income communities to take advantage of the money that is available through green banks, through CDFIs. Corporations and nonprofits are stepping up through low interest loans and actually direct grants at this point. So the Biden administration is pushing money down into these communities to help them. And I am working to connect them with that money. And I'm very hopeful that they will be included in the solar revolution shortly. Organizations where you can learn more, you can see right here. I'm not going to read them off. I'll let that set for a second. And I'm going to move on to my optimistic close. So it's a time of hope. It can be a scary time, but it's also a time of hope. And this last year has been a real pain. As I said, I have a son who was 16 when the pandemic started. He's 18 now, and we're climbing the walls in my house. I get it. The pandemic is awful, and it's been awful for many, many people. But it's caused humans to slow down, and the planet takes advantage of those breaks. The planet is looking for that chance to rebound, to bounce back, just like humans, just like any other living organism. Given the chance, we will take it. And so life slowed down during the pandemic. And you can see, this is courtesy of the European Space Agency. These are photos of Venice, and the boating traffic decreased dramatically during the pandemic, and the water quality began to improve. So the top pictures of the improved water quality, you can see the turbidity stirred up by the boating traffic is gone or greatly reduced, and that system is beginning to rebound. Again, European Space Agency, and this is focusing on nitrogen dioxide levels, and they decreased dramatically in France, Italy, and Germany. Nitrogen dioxide is released into the air when fuel is burned, and it harms the health of young children, the elderly, and those with asthma because it irritates the lungs. And it also mixes with chemicals in the atmosphere to form acid rain, and that harms water quality. So you can see on the right-hand side that those big red zones are dramatically decreased. And that peace and that time of quieter activity has been helpful for the planet. India, sulfur dioxide emissions decreased by 40%. And sulfur dioxide is emitted into the air from power plants and other industrial facilities, as well as volcanic eruptions. We can't ignore that part of it. And sulfur dioxide harms the children, elderly, and folks with asthma and contributes to acid rain. With the installation and growing use of green energy, then hopefully the Earth will be able to continue to rest and recover the way that we're seeing it quickly did during that 1 year of pandemic rest. We're going to close with a very famous photograph, and this was taken during the Apollo 8 mission. And this is the moonrise of 1968. This was the first manned mission to the moon, and this photo was not on the schedule of photos to be taken, but the astronauts broke protocol. And command module pilot Jim Lovell said while orbiting the moon, "The vast loneliness is awe-inspiring, and it makes you realize just what you have back there on Earth." End of quote. solar energy and other green energy technologies will allow us to improve air quality, improve health, decrease fossil fuel demand, and rebound from climate change. As we saw with the pandemic, when given a chance, the Earth will take it. Increasing green energy production, reducing energy use, particularly fossil fuel energy use, they are the chance that the Earth is waiting for, and solar energy can be a tremendous part of that. So if you have any questions, you can find me at this email address, lcombs@Eagle Solar and Light. There's my company's website. There is my dog on the left, because a dog should always be in a PowerPoint presentation. And give us a call. And if you want to reach me directly, drop me an email, and I am happy to answer any questions or provide any follow-up research that's needed. And I think that's about it.
All right, wonderful. Thank you so much. We've gotten a few questions and a few comments as well. So John was talking about that they didn't know that solar could be so economical. So thank you for elucidating that. But we also had a question of, do you know of any additional rebates or tax incentives coming to residential homes?
So a couple things. Solar definitely can be economical, and there are a number of incentives, and I was going to go into that, but I stopped myself. So at the federal level, there is the investment tax credit, and residents can take care of that, or can take advantage of that. And then businesses can take advantage of the investment tax credit. It's 26% directly comes off of your income taxes. And businesses can also take advantage of the 100% bonus depreciation that can be taken all in 1 year. So there are federal incentives in that regard. And at the North Carolina level, we have the rebate program with Duke Energy, and the nonprofit rebate program is the most advantageous as far as generosity. And the residential and commercial sector rebate program has just been modified, and it's going to twice a year. I think that the next window of opening to apply for those rebates is July 7th. And actually I have slides about that. I just suppressed them. And they have changed the rebate amounts. And I want to say that commercial is, I'm going to get this wrong, 30% and residential, or 30 cents, and residential is 40 cents per watt. So, darn, that's on a slide. But anyway, so yes, they've changed the configuration of the rebate program, and July is the next rebate window. And I have this great slide. Rebate window in January was used in 2 minutes and 41 seconds for Duke Energy Carolinas, and like 2 minutes and 6 seconds for Duke Energy Progress. Like, all that rebate money was gone. So wow. Folks are going to apply for rebate. They need to be sitting there as soon as that window opens and submitting those applications. People can install solar and then apply for the rebate afterwards. So if folks are interested in installing solar and they want to do it now and then see if they get the rebate later, they can. It really is just, all about the luck. But for nonprofit organizations, there is enough rebate capacity that they can use that at any time of the year. And my company is, we have partnered heavily with tax exempt and nonprofit organizations, and we're able to often create solar savings for them in the very first year. So it's a great time to investigate solar.
Wonderful. Thank you. We had a question. You mentioned the solar sidewalks that you knew someone was working on. And we had a question in chat about solar roads. Are those in our future as well as sidewalks? Do you know?
I wish I had an answer, and I don't. It would be a brilliant idea if that could be engineered. And I wish I had my friend Aiden on here real time to talk to him about it, but he's not here. He's amazing. These young people in college are incredible, and I'm so hopeful and so grateful to them. But I really don't have an answer for that.
No, that's great. That's something that I should look into too, because I'm curious about how those are progressing. We had a question in the chat as well. When the lifespan of solar panels ends, is their waste harmful to the environment, or can they be recycled or anything?
So yes, that's a great question. And so solar panels are tremendous. They do tremendous work. And that needs to be addressed from the beginning and also at the end. And there are environmental consequences with anything. We have to mine the materials in order to create the solar panels, and that has its own environmental impacts. And I used to review projects similar to that as a state government employee. So there are strong efforts to try and reduce and minimize those impacts. But I think absolutely the trade-off is worth it to create those panels. And then as far as at the end of life, there is growing effort to recycle solar panels. Europe is ahead of the United States in that regard. But as with everything, trends travel, and I'm sure that I have full belief and confidence that we will develop a way to properly recycle those panels. And panels are becoming more efficient all the time. And just like the technology, we started in 7 BC, and then by 1400, Copernicus starts the scientific revolution, and everything goes faster and faster and faster. And new battery ideas are coming out. I see there's a mention, we didn't discuss batteries and we didn't have time for that. But these technologies are changing and becoming so much better so quickly that it's, for me, hard to even anticipate where we're going to end up next. And maybe in 5 years, we will be having guys on the roof painting on solar panels. Who knows?
Yeah, that's true. That's true. All right. Well, I think that's all we have time for today. But thank you so much, Laura, for speaking with us and kind of giving us overview of solar energy and also the cool things that are coming in the future. And thank you for everyone for tuning in with this talk. We hope you had fun and learned some new things. We'd like to thank the Biogen Foundation and North Carolina SciFest who help support our SciTech programming this week. And as always, thank you to our members of the museum who support us every day and help make events like SciTech happen. There are other great programs scheduled for this week, so we'll post a link to the schedule to register for those. And finally, the recording of this program will be available on our museum's YouTube if you wanted to rewatch that. Thank you so much for attending, and we hope you have a great rest of your day.
Bye-bye. Thank you for the opportunity. Thanks, everyone.
Thank you, Laura. It was great. Learned a lot.
Thank you.